In this video, we will be looking at the properties of logarithms and then using those properties to compress an expression into a single logarithm. Our properties of logarithms: when you have the log of a product, you can rewrite that as the sum of the logs of each of the factors. Or if you want to work it backwards, if you have individual logs that have the same base, then you can rewrite that as the log of the product of those two arguments. Property 2, the log of a quotient is equal to the difference of the logs. Or if you have subtraction of two individual logarithms, you can write it as a single logarithm expression, but the arguments are divided. If you have an exponent on the argument, you can bring that exponent out in front of the logarithm. Or if you have a product of some number times a logarithm, you can, if you like, take that factor and write it as the exponent on the argument. And then property 4 is the log of 1 is equal to 0. And this comes from a to the 0 power equals 1. And then property 5 is the log of an argument, and if the base is the same number, is equal to 1. And that comes from a raised to the first power equals a. Alright, we're asked to write each expression as a single logarithm with the coefficient of 1. Sometimes this is called compression. Our first example, we have subtraction, which is an indication that we'll be using property 2. And we have addition, which is property 1. Since I know I'm going to be using property 2, I'm going to write this as a single log. The base is 4, and I'll have a fraction. This logarithm is positive, so this argument x is going to be a factor in the numerator. This log is negative, so this argument y will be a factor in the denominator. And this logarithm is positive, so this argument z will be a factor in the numerator. Our second example, I'm going to use property 3 first and take this factor and write it as an exponent on the argument in the same way here. So this is the log of r to the 4th power, base of b, subtract the log of s to the 5th power with the base of b. Alright, now since this is subtraction, this is property 2, we know that we can divide these arguments. So this is the log, the base of b, of r to the 4th power divided by s to the 5th power. In this example, I'm going to use property 3 first to take this factor and write it as an exponent on the argument. I'll do that with each of these. And this one doesn't have a factor out here. So I have the log of x to the 1/3 power, and the base is a, plus the log of y to the 2/3 power, and the base is a. Now, since I'm compressing this into a single logarithm, I'm not going to use my first property to expand this. I'm just going to leave it as the log of x times y. And since I have subtraction here, that means that I'm going to have property 2 involved, and then this is property 1. So as a single logarithm, I have the log base a, and property 2 calls for division, so I needed this fraction bar. This logarithm is positive, so x to the 1/3 is going to be up in the numerator. This logarithm is positive, so y to the 2/3 also is in the numerator. And then since this logarithm is negative, this argument will be down in the denominator. Now, since both of these are to the 1/3 power, that's a cube root, so I could rewrite this with a radical. Just depends on what your directions call for. But both of these are to the 1/3 power. So if I have 1/3 power, that means it's a cube root. And then the x to the first power would be a factor of the radicand, and y to the second power would be a factor of the radicand. And then xy is in the bottom. Both of these would be acceptable. Now we can continue to use our properties with this example. We're asked to assume that the log of 7 base 10 is 0.8451. And then that's all that we're given, and we're asked to find the log base 10 of 49. Now, since I know the log of 7, I can write this argument as 7 squared. So let's do that and then see what we have. This will be the log base 10 of 7 squared. Now, property 3 allows me to take this exponent and write it as a factor out in front. So this is 2 times the log base 10 of 7. Now this log of 7 base 10 is what I'm given up here in the directions. So I can take this factor, log of 7 base 10, and replace it with 0.8451. This product then is so the log of 49, given this information, the log of 49 with base of 10 is 1.6902. Let's try another one with the same directions. Again, I need that log of 7, so I'm going to rewrite this argument as 7 times 10. So I have the log base 10 of 7 times 10. Now I know property 1 allows me to write this as the log of 7 plus the log of 10. So let me do that. This log of 7 is what we were given up here in the directions. So I can replace this with 0.8451. This, I know from property 5, is equal to 1. So I'm going to replace that with a 1. Now if we do the math, we have 1.8451.